Okay, so what is actually space switching? And this is not a simple question, because space switching involves a lot of different tricks and it can be done in a lot of different ways, but essentially space switching is like a number of various techniques which is meant to make your life as animator simpler and help you to create animation in a faster and easier way. So here I prepared a few examples. Like some time ago I created some prototype of a first-person shooter, and here on the image we can see hands and weapon. And technically, as the weapon should follow the right hand, it's much more convenient to create some extra locator, parent weapon and both hands to this locator, and just animate everything with this one master locator. In the next image, here we can see a custom locator, which works like a pivot point to rotate the hand around the weapon, and same for the other hand. We can place a special locator in the handle of the weapon and create these subtle adjustments of a hand without having to animate an actual rig. There is another example with a third-person locomotion and the combat system I was working some time ago. It was all made using the other rig from game anim. So here I have a scene from this project, and we can see the character performing some attack. It's kind of a draft animation, but the idea is clear. The character is manipulating the sword like a two-handed weapon. And again, I know in this rig there is some space feature included to make the sword follow either right hand or left hand, but essentially when we work on the animation, it's much more convenient to animate the sword itself and make the hands follow this sword. So here I created a system of locators. Some locator are following the main. Inside we have the sword control and special controls for hands to rotate them like this, or for example like this, and it's all much more convenient than animate the rig directly. So at some point the space switching can be defined like using locators and constraints and creating some mini rig in your scene, but again the space switching is a very wide topic and it has a lot of techniques. I think the first person who introduced the space switching as a comprehensive approach maybe was Richard Lico, but personally I never watched his tutorials. I had to figure out space switching on my own mostly. Then in the year 2018 I took an animation class from Dmitry Kolpakov, and it expanded my knowledge of space switching a lot. So to use space switching we're gonna need some scripts. You can use my script or any other scripts which have some similar functionality. In fact, it doesn't matter. You can use free scripts, for example the LM locator script. It's a very nice script and it is completely free. I will put a link in the description. I think at this point the biggest problem is there are too many scripts and you easily can get lost. So today I'm gonna try to explain the logic which stands behind all these techniques, and once you understand it, you can figure out the scripts part basically on your own, and you won't be chained to use any specific script, because like I said, it's essentially just locators and constraints, and I think everybody should know how to use them. I would like to start maybe with the curve filters. We already saw how the curve filters work in the previous tutorials. So we can select some animation curve, apply some smoothing. We can also play with the interpolation, from linear interpolation to is in, is out, or is in, out. We also have these buttons with the presets. So it's all kind of obvious and intuitive. And visually it obviously looks very similar to the animbot, which also has similar tools to work with animation curves, except my tool has a couple of major differences. So the first very important feature would be that these curve filters, they understand quaternions, which is very important when we work with rotations. So for example here we have a cube, and this cube has, let's say, some glitch in rotation, which we would like to smooth. So the animation curves of the cube looks like this, and it has gimbal lock in these curves. And if we try to run Euler filter, it won't change anything. So by default, if we use any other smoothing tool which doesn't use quaternions, we will get not very good behavior. So for example here we gonna smooth those keys without using the quaternions, and as a result our glitch behaves kind of weird because of this gimbal lock. Again, let me undo. So before it was like this. And when we apply some smoothing without quaternions, we get a behavior like this. Basically because how earlier rotations work. I can maybe try to visualize the motion trail on a locator inside this cube. So you can see as a result the cube is kind of moving in this direction a little bit, which is very annoying. Let me undo this and run the smoothing with quaternions enabled. So when I smooth rotation with quaternions, animation curves look a little bit differently, but the result is a nice and clean rotation without any weird behavior. And again, if I visualize the motion trail, it will be a very clean result. Honestly, I kind of lost count how many times I had this problem when I work with some long animation and it has a little bit of glitching and I just want to smooth it a little bit, and any smooth just makes the animation worse. So personally, I think this is a very cool, very helpful feature which can potentially save you a lot of time. And Maya also has some smoother. Here, for example, we have Gaussian smooth, and it also claims to understand quaternions, but if I apply this smoothing, again, the result you can see, it is kind of weird. The trajectory is super bad, and we completely lost our animation curves. So honestly, I don't know how this native Maya smooth works. It obviously doesn't work for me, and if we use a script with quaternions, we don't have any similar problems. It just works nice and clean and allows you to smooth rotation. And the same works for other filters like interpolation. Again, nice and clean rotation. So if you have some gimbal lock issues, you can just select rotation curves and apply desired interpolation, and it will just work. Even if in the graph editor it might look a little bit weird, the result rotation should be fine. If we want, we can apply more iterations to our smoothing. In case you have some really noisy mockup data, you might want to apply more iterations to your smoothing. We can also do like reverse smoothing to increase the differences in the animation curve, and we also can play with the intensity of the animation curve. And it can be really helpful when you work with the pelvis correction or some similar cases. And be careful, in order to use quaternions, you have to select all 3 rotation curves. If you select only 2 rotation curves, or select unequal amount of frames in rotation curves, the script will return warning, and it will treat these animation curves as simple animation curves, but not quaternions. So you need to select all 3 rotation curves and make sure the frame count is the same. Then it will work as intended. And another major difference in these curve filters is that it's optimized to work with a baked animation. So for example, here I have some animation with 500 frames. Let's say it's some part of some mockup, and I can easily apply the smoothing. You see it kind of works real time. Even at such long animation, the script has no problem to process this number of keys, because everything works through OpenMaya and it works kind of fast. Honestly, the hardest part of creating these curve filters was figuring out how to implement the undo and redo. I had to write a plugin to do this, but eventually it works. We can play with the undo or with redo, and everything should work fine. For start, I will presume you're already familiar with the elementary knowledge. You probably know that you can create locators like this. That locator is essentially a transform node with some locator shape inside. You can assign some colors, for example here in the locator shape. If you go to the drawing overrides, you can assign any color you want. You can play with the scale of locator here in the locator shape, but not with the actual scale of the transform node. Please change the shape scale. You can create structures with locators, like parent them one inside of other, to create some sort of temporary rigs in your scene, kind of like this. And constraints are essentially nodes which allows you to make one object follow other object. For example, parent constraint replicates the parent-child behavior. The point constraint makes one object follow other object by position, but not by rotation. Orient constraint makes one object follow other object by rotation, but not by position. And there is also aim constraint, which makes one object control rotation of another object. So this is all very basic stuff, and if you have no idea what is happening, I would suggest you to maybe check some elementary tutorials, because we're not gonna stop much on this, and we're gonna jump straight to the space switching. So when doing a space switching, we need to create locators a lot at some specific transforms. For example, here I have a cube jumping, and let's say I want to create locator at this point. I can use this free anim locator script. It will create me locator at the cube position. Also, I can create locator at some vertices. For example, here I got locator at this point. I can create locators in the average position of some vertices, which also can be helpful, kind of like this. If you want to bake some animation to locator, for example this cube, it is kind of jumping, I can double click on this free script and it will create me animation snapshot of this object, where all animation will exist on this locator, and this locator will be in the world space, kind of like this. If you want to create animation snapshot manually, again, you can just create locator at point, constrain it to your object, constrain parent. Now locator will follow your object, and all you have to do is just go to the animation, key, and bake simulation. Well, this bake simulation is kind of slow. There are ways to speed it up. I'll explain it in a second. And in Smart Layer, you can find these functions here. So first button will create a locator at point, and second option will make an animation snapshot. By the way, you can see that the bake was much faster than the standard Maya bake. It's because the script is kind of smart. It is able to estimate the bake time with different settings and choose such settings which would make the bake as fast as possible. And again, you can create locators at some specific geometry or some average position of some vertices, or for example some face. And you can create animation snapshots of geometry as well if you need it. For example, here I have some animated geometry, and let's say I want to track some positions of some faces. I can simply make animation snapshot, and I got this animation baked to the locators, kind of like this. I can play with the scale of locators with these buttons. I can also assign some color if I need. And overall, the scale of locators can be kind of annoying. For example, if I have the scene in the meters, but not centimeters, if I create locator by the free script or with the standard Maya tools, the locators will be kind of huge, which can be very distracting. And it's kind of hard to scale them with these attributes, because the values here are not very convenient to operate. And in Smart Layer, basically I can go to the settings, object size, and choose a desired size of the locator, which would be convenient to use in your specific scene. So here in Smart Layer, I have locators created with exact precise size from the settings, no matter what units are used in the scene. So the first case where we can use the space switching and animation snapshots would be if we want to track some position of the object in the world space. So for example, here I have an animation, and probably you know that when we create some animation, we need to track some positions in the world space. For example, here we would like to track the positions of the feet, like exact motion trail in the world space, of the knees, of the pelvis, of the chest control, also the elbows, trajectories, maybe the head, and maybe the hands and the sword, as well as the sword tip. So if I would like to do this using just regular controls, it might be a little bit problematic. So for example, here I have some weird movement of the knee, and if I go to the graph editor, I basically see nothing. I have no idea what makes this movement, because this control follows the IK foot, and the space switching can help us a lot in this case. So if I create animation snapshot of this object, I will get the position of this object baked to the world space, and I will see the real movement of this object shown in the animation curves. And right now, the locator, it exists kind of separately from the actual rig control. So what we can do is just select the locator, select our control in the rig, and just run constraint point. So right now, our locator, it exists in the world space. We can see real information about its position in the animation curves, and this locator controls the behavior of our object from the rig. So what we just did is basically called to bake object to the world space, and in Smart Layer it can be done with this button. I can simply select the required control, bake it to world space, and again I will get the locator in the world space with real information about the movement, and this locator will control my initial object. So for example here, maybe I can create the motion trail for this locator, and I will instantly see problem spots. Maybe I can smooth keys a little bit here. Just select the required keys, go to the curve filters, and apply a little bit of smoothing. Just be careful not to smooth things too much, not to change the length of the leg segments a lot. Maybe some smoothing can be applied here. We can see some knee pop. If you want, you can create some animation layers to adjust this extra locator. For example, like this. In animation layer, I can create some keys to play with the pose and apply some adjustment. And with this technique, the polishing of animation is going much simpler, much easier than if you would have been animating this control directly without seeing its keys in the world space. So after adjustment is done, let's say I'm happy with this adjustment, I can simply bake this rig control using the bake button and delete extra locators from the scene. For example here, I can simply delete this locator, or if I have many locators, I can simply press this button. You see that there is a space switching selection set, and this button, it deletes all locators from this space switching selection set. And again, you can use this technique to polish a lot of controls, maybe the chest control. Again, I will see all keys in the world space. Okay, these keys are kind of smooth already, but you should keep in mind that you don't have to do smoothing all the time. It's only for the cases where you really need to use it, when you see some glitches or inaccuracies in the animation. And the crucial part of work is done on the blocking stage. Don't forget to look at the poses. Don't abuse the smoothing a lot. If you smooth everything every time, it can actually make your animation look worse. And also, I forgot to mention, so basically when we bake something to the world space, the timeline selection is supported. So if I don't select any time range, when I bake the object to the world space, I will bake the whole timeline. If I select some part of a timeline, I will bake animation to locator at this specific time range. So before this time range, the locator will make no impact. During this time range, the locator will control our object. After the time range, again, the locator will make no impact. So if you have some long animation, you can bake the object at some specific time range. You can do it on multiple time ranges. For example, like this. Here the object does not follow any locators. Here it follows this locator. Here it follows our first locator. And yeah, and the whole system is kind of flexible. So this snap mechanism works through regular constraints. So basically when we bake some object to the world space using the locator, we create some point and orient constraints, and the script automatically sets keys on these constraints depending on the selected time range. And the same logic applies to other options in the script, not only back to the world space, but also back to selection, or back inside, or IK, or back to the aim space, and we will review all these features later in the tutorial. So you might have noticed that in all videos I use animation with an animated main control, with character movement baked to some sort of root motion. And the main reason to keep animation like this is just because it's more convenient to manipulate the character, like move it in space, or for example to rotate the character and adjust the animation, or maybe apply some poses, because the poses in the pose library work relative to the main control. So I can put my character in any spot and apply a pose from the pose library and it will work okay. But when we actually working on the animation, it's more convenient to keep the main control static and keep the whole animation in the world space. So when we're working on game animation, we can actually easily switch between the animated and the static main control, depending on the circumstances, and we can do it very quickly with the space switching. So for example here, if I want to switch to the static main, I can go to the graph editor, select the main control, and simply mute this animation curves. Curves, mute channel. And I will get my animation in place, because the main control is static. If I would like to keep the animation as it was before muting the curves on the main control, I will unmute them. I need to bake this animation to the world space. So I will select the IK controls and pelvis and maybe pull vectors and simply bake them to the world space. So right now the controls are following the locators from the space switching, and I can animate the main control without affecting the rest of the animation. So if I mute the animation curves, mute channel, I will get animation in the world space exactly as it was before, and the main control will be static. So let's quickly bake our IK controls, just bake and delete locators, and you see I got my animation in the world space and the main control is static. If I would like to convert this animation to the animated main, again it's super easy to do. I will select my IK controls, bake them to the world space. Now I can animate the main without affecting the rest of the animation. I can simply unmute the curves unmute channel, and I can animate the main control manually, or maybe just keep these old keys, but after I bake the IK controls and delete locators, I will get my animation as it was before. So you can see it's kind of super easy to switch between static main and animated main, so you can easily perform the switch depending on the specific task you're trying to solve. If I have animation like this, where the main control is not animated by any way, I don't have any keys on the main control, and it is somewhere far away from the animation, and we need to recreate its animation according to the character movement, we can use the root motion extractor option. So root motion extractor allows you to take a movement of some control, which would be like a center of mass of your character, and bake it to some simplified movement, which can be used as root motion. If you don't have any root motion extractor, the simplest way to get the root motion would be just to select the pelvis control and create animation snapshot. So this animation snapshot exactly repeats the pelvis movement. So if I delete the rotation keys, set rotation to, let's say, 0, and remove keys from the translation Y, which is up axis in this scene, simply set the translation Y to 0, you see that this pelvis movement roughly matches the movement of the character, and it already looks like some kind of root motion. Basically, same stuff can be done with the root motion extractor. So I will delete all animation from this locator. Just imagine if we created locator and put it somewhere below the character and call it, I don't know, root motion. So right now it's just simple locator without any keys. And to use the root motion extractor, I need to select the source of the root motion, which would be the pelvis control, then the target, which is this root motion locator, and just press extract root motion. So it worked super fast, and it extracted me root motion of a character to this locator. We can see we got some translation and also some rotation, which matches the rotation of a pelvis. If we don't want to have any rotation, we can disable this checkbox. And also when we work with simple walk cycles or movement cycles, I would say we need only the forward component of a movement, not movement to the side. So we can use this straight line checkbox. So I will delete the keys, select the root motion source object, select the target, and press extract root motion. So the root motion is extracted. On this locator I don't have any rotation keys, and the movement is working on the straight line, which is very convenient when you work with the movement cycles. Obviously we would like to animate the main control, similar to this locator. So I used locator just for demonstration. So to actually extract root motion to the main control, first we need to bake our key controls and pelvis to the world space, because right now the main control, it affects the all animation. So I will select the key controls, pelvis and pull vectors, bake them to the world space. Now I can move the main control. I will put it somewhere under the character. So for example, I don't know, maybe make it 0. Maybe in your case you would need to use some match translation option. In my case, I simply know that the translation 0 matches the correct position of the main. So again, main control is static. I will select pelvis as a source of root motion, then the main control as a target, and simply press the extract root motion button. Okay, root motion is extracted. Super fast, super easy. I have all necessary keys on the main control. Now I can select my key controls and pelvis, simply bake them, and delete locators. And I have animation with the animated main control. So I can use the correction by spline or any other features of the smart layer. So that was a very simple example, and if we have some complex movement, we can also extract the root motion. It's not a problem for the script. So here I have a long walk animation with multiple turns and also some lanes, and I can use the root motion extractor to animate the main character in this scene as well. So same as before, to extract the root motion to the main control, first we need to bake the pelvis and key controls to the world space, just to be able to animate the main control. Okay, just bake it to the world space. It's baked. And now I need to move the main control somewhere under the character. So maybe I will use the match translation, right? And then I will set the translation Y to 0. Maybe rotate the main control to match the direction of the character. Something like this. And same as before, select the source of root motion, which would be pelvis, then the target, which is the main. Enable the extract rotation checkbox if you want, and just press extract root motion button. Okay, root motion is extracted. Super fast, super easy. We can see that the main control is repeating the movement of a character. We can see some turns, and everything is evaluated correctly. Again, there are no glitches in rotation, and we can use this movement as a root motion. So same as before, when the root motion is extracted, we need to select our key controls and bake them. and delete locators. And now we have our animation with the animated main control. If we mute curves on this main control, curves mute channel, we will get animation in place, which can be more convenient if you want to polish our animation. So if you would like to extract motion manually, using only locators and constraints, we can still do this, but we would have to solve a couple of issues. So for starters, we'll have to bake our key controls to the wall space, same as usual. I will select key controls, bake them to the world space. Now I can animate the main control separately. I will match it with the pelvis by translation. Then I will set translation Y to 0 and roughly rotate to match the character direction, something like this. Okay, and the first problem, if we try to constrain main control to the pelvis, we will get a cycle, because the pelvis control is already follows the main. So if I try to run some point constraint, let's say like this, I will instantly get a cycle, so we cannot do this. And the solution will be to create animation snapshot for the pelvis. You already know how to do this manually. So I created a separate locator with a pelvis movement. I will call it, let's say, pelvis. And I can constrain main control to this locator using constraint point with offset and using only Z and X axis here. Okay, so after we created the constraint, the main control will follow the pelvis. We got our root motion by position. And the second problem, if you would like to extract rotation with orient constraints, it simply will not work. So let me show what I mean. If we pick, let's say, only axis Y and create an orient constraint, we will get a lot of glitches. So here we got some rotation, but here we can see we have a glitch. Here the evaluation is incorrect. Here we have a glitch again glitch. So with orient constraints you absolutely cannot extract rotation. It will produce incorrect results. So I will delete this orient constraint. And under the hood, the script uses some vector mass in quaternions. I think we can maybe replicate it with the aim constraint and a couple of extra locators. So I will create an extra locator for the pelvis. Call it maybe forward. Parent it inside the pelvis locator and move it like this. So this will be like a forward direction to the aim constraint. Also we need to get the movement only in the horizontal plane without any vertical movement. So for that I will create another locator, call it aim forward. Maybe reset rotation, maybe set the translation Y as 0 and maybe assign a different color. So we will use this locator to drive aim constraint to rotate the main control. So right now we need to transfer animation of this locator by position in horizontal plane to this locator. And we can do this through the node editor. In the node editor we can see something interesting. So this locator, its shape, it has the world position attribute. And we can use it as a source of the translation for our aim locator. So I will simply plug the world translation X here and the world translation Z again here to our aim locator. Now I can close the node editor and this locator, it will follow the forward direction of our character, but it will stay in one horizontal plane, kind of like this. So right now we can select this locator, select the main control and create the constraint aim. So with aim constraint we need to maintain the offset. The aim vector will be Z, so it will be like 0, 0, 1. The up vector will be Y, so it will be like 0, 1, 0. And the world up type we can choose as a scene up. Okay, so it kind of worked. We have rotation on our main control. There are no glitches, no flips. Everything works kind of stable. And basically at this point all we have to do is just bake all controls and delete locators. So I will select my controls, bake, delete locators, and we got our animation on the animated root control, and we did basically everything manually. So with this technique you can animate root motion on any animation, would it be some mockup which doesn't have root motion, or maybe some keyframe animation. Overall, the root motion is not such easy topic as it looks like. There are a lot of unobvious moments how to animate root motion. Personally, after many years in the industry, when I'm doing animation for games, in almost every case I do some manual adjustments to the root motion. If you would like to know more information about this topic, maybe I could create a separate tutorial, because again, there is a lot of stuff to discuss and it can be a whole separate long tutorial. Another very important technique in space switching would be to make object to some custom pivot point. For example, here I have animation of character attack, and we can see that the foot control is kind of rotated around some custom point somewhere here. So if you would like to work with this animation, ideally we would like to animate not the foot control itself, but animate it relative to some custom pivot point. We can do this manually. So to do this manually we would have to create some custom locator, say like this, then move it to the desired spot somewhere here, where would be the pivot point of the rotation. So right now it's just a locator, it doesn't do anything. And in order to adjust the foot animation relative to this locator, we would have to run a parent constraint first. So constraint parent with offset. So this locator will follow the foot. Then we need to bake it, delete constraint, and we got this locator repeating the foot movement in exact position we need. After that, we can simply select this locator, select the foot, and run constraint parent. So the animation is not changed, but right now this locator, it controls the foot behavior, and we can see its keys in the world space. For example, we can see the areas where the foot is sliding. For example, here we can see some sliding. We also can see some jiggling by rotation, and we can work with this locator directly to polish our animation. So I will delete this locator to show you how to do this with a smart layer. In smart layer it can be done with this button to bake object to selection. So we need to first, as usual, create some locator, put it in the desired spot, kind of like this. Then we need to select our object, our locator, and simply press bake to selection button. Okay, so the bake is done, and I have this locator controlling the foot movement, and I can see all keys in the world space, and I can work on this animation. I can do the same for the other foot. Again, create locator, move it into the desired spot, select object, select locator, press bake to selection, and I got all animation on this locator with real coordinates in the world space, where I can understand the feet behavior. So for example here, I can see this control is jiggling a little bit by rotation. So I can select the rotation keys and maybe apply some smoothing. Simply select the keys and run the smooth in the curve filters. And the jiggling is kind of gone. If I want, I can create animation layer with this locator. So let's say from this frame to this frame, I would like to keep the same position. I can simply select this time range and press this button to fix the control in space by position. And you see the sliding by position is gone. And in this way, you can do the cleanup of your animation very quickly and easy. And animating the rig control itself would be a very painful and a long way to do this. So these buttons, they allow you to copy pose and set keys over selected time range. So for example here, right, if I want to keep the same pose by position on this control, right, so I will delete these keys. I can do this manually. I can basically copy pose through middle mouse button and set key, but that's kind of long way to do this. And I will also copy pose for rotation as well, so I will have to delete keys from rotation to keep only position. You see we got sort of counter animation on this layer, and basically I can do the same with simply selecting the desired time range and pressing one of these buttons. I can set keys on all attributes: translation and rotation, translation, rotation, or scale. So we will choose translation. And in this way you can snap the foot position to the desired spot. And maybe we can quickly do the same for other parts of the animation. For example, from this frame to this frame, I think we can, let's say, snap position. Steps here, okay, here the position is snapped. Okay, here everything is fine, so maybe we can create another layer for this locator. Set a few keys. Okay, here we can see some sliding. So from this frame to maybe this frame, we would like to keep the same translation. And maybe also from this frame to this frame. So I will select this time range and press set key by translation. And I get the foot sliding fixed. You see, basically spending a couple of minutes, the animation is adjusted. There is no feet sliding. We kind of fixed some glitching by rotation, and all of it can be done with the space switching and curve filters really quickly. So after the adjustment is done, again, I can simply bake it. I can bake it to layer or bake it to the original animation and simply delete locators and delete these animation layers. And my animation is adjusted. And also I forgot to mention, so this feature, set keys in the wall space over a selected time range, it obviously works not only with some locators, but with the rig as well. So if, let's say, I have some, sliding in the rig, and I want to work with the rig directly, not with some locator, again I can edit the layer, set, let's say, a few keys. Maybe here I will set a key with 0 value, and I want this foot be fixed in space. So I can select the time range. And as I started the selection from this frame to this frame, the script will simply copy pose, again from this frame to this frame, and just set keys. And if we go to the graph editor, you will see that the script, it set keys to preserve the pose from this frame over this selected time range. And if you want, we can set more keys. For example, here the feet is sliding. Again, maybe I will set keys with 0 value, maybe somewhere here, maybe here as well. And let's say from this frame to maybe this frame. I can set the same key by position. And because I started selection from frame 7 to frame 13, it will copy the pose from this frame over this selected time range. Again, the feature is very simple. It's essentially just two commands in Python, just set position and set key, but it's kind of very convenient to use. Another very important technique in space switching would be to bake one object inside other object. So for example, here I have a cube, which is kind of jumping, and I have also some sort of platform, which is separate from the cube. So if I would like to manipulate these objects together, preserving the original animation, I can simply select the cube, select the platform, and press bake animation inside. So we can see some additional locator is created in the scene. Animation looks the same, but right now the movement of this cube is calculated relative to this platform. So I can manipulate the platform and the animation of the cube will be changed with it. So the technique is very simple, but it has a lot of applications. For example, this case. So here we have a character doing some walk animation, and this character has hands animated with the eye key. So if I would like to adjust the pelvis position, kind of like this, my hands will stay in place. So it can be a little bit inconvenient to manipulate the character when the hands are always staying in the world space. And we can easily bypass this limitation if we simply select the hands, select the pelvis, and bake hands inside the pelvis. So animation will not change, it will stay the same, but right now our hands IK, they exist in sort of inside pelvis animation space. And we can adjust our animation, play with the poses. Our hands are still working through the IK, but there is no problem to manipulate the pelvis object. For example, here we have a character which is climbing some object, and if you would like to manipulate this animation, it will be a little bit hard to do using this main control. So in a lot of cases we would like to manipulate our character using some sort of center of mass. Maybe in this case it can be somewhere here, or maybe somewhere here. So again, we can create some animation snapshot for this control, make it bigger, and simply bake our objects like the pelvis, the main, maybe the eye case. Simply select our objects, the locator, and press bake inside. So animation will be not changed, but right now this locator, it acts like a new main control. So it's easy for us to manipulate the character. And again, depending on your specific situation, you might want to create some completely unique main control. So for example, here I have a character performing some flip animation, and as you might have guessed, it will be not convenient to rotate character around the pelvis point or maybe around this point. Again, it will be not exactly correct. So when the character is jumping in air, ideally we would like to manipulate this character around some sort of center of mass. So basically, when the character is in air, it is flying on some sort of ballistic trajectory, and the rotation of a character happens around the center of mass. And the center of mass has always a different position. So when the character is standing, it can be in the pelvis point. When the character is taking pose like this, the center of mass will be somewhere here. When the character takes a different pose, the center of mass will be again in a different position. So manipulating the character in air to create a correct ballistic trajectory is kind of a complex task, and it's very hard to do without space fetching. So if you try to search, you can find a center of mass proportions for regular human, and then you can create a locator, call it, let's say, center of mass, and then simply recreate the correct position of the center of mass using the simple point constraints. So I will select some bones of a character and create simple point constraints to this locator to replicate the center of mass behavior. Constraint point without the offset. Then I will maybe use the spine and the hands. Constraint point, and also I will select the neck and maybe the head, and again run constraint point. So I have this locator and I have these weights of specific constraints, and now I can set the weights matching the percentages of mass of a real character. So I roughly set the values of the weight of the point constraint of our center of mass, and the center of mass locator is somewhere here. Maybe I can assign some different color. So as you can see, when the character jumps, the center of mass will be in some point somewhere here. So after I got the correct center of mass behavior, I can simply make an animation snapshot and maybe hide this locator, which is constrained, and then use this animation snapshot to switch space inside. So I will select the feet controls, the pelvis, maybe hands eye key, and switch them inside this center of mass locator. Okay, the space is switched. Animation looks the same, but I can manipulate my character using this center of mass locator. And when I rotate it in air, kind of like this, the rotation will work correctly in every point of the animation. So if I want, I can create, let's say, another animation layer, maybe apply some extra rotation, maybe even do one more full turn. Just make sure the keys in the layer will be linear, because when the character is flying in air, the rotation is applied in a linear way. So we got, let's say, a double flip animation. Of course, this is kind of ridiculous example, but you see the idea. You know, if you want to manipulate the character in air, in order to get the correct physics, you need to use center of mass. And the space switching inside can help you a lot in this process. Okay, maybe I'll remove this double flip. Also, you can play with the curves. Here you can see the ballistic trajectory. If you don't like any movement, let's say here, you can maybe smooth it, or apply some correction, or apply some extra rotation. And it's all much more convenient than if you had tried to manipulate the character using the pelvis, constantly rotating, then moving. Again, it would be a nightmare. So with the center of mass, these kind of manipulations are much quicker and much easier. Overall, the center of mass and the whole ballistic movement are kind of advanced topics, and these topics go beyond the simple space switching tutorial, but I hope you kind of got the idea. And also one of my favorite examples would be if you want to modify some attack animation. So here we can see the character is performing some attack, and the weapon is essentially a box which is constrained to the hand. So if you would like to work on this animation, it will be kind of inconvenient to do. So like it was shown in one of the previous examples, with this character performing an attack, we can animate the weapon itself, and the hands can follow this weapon. So for example here, I can select the weapon, maybe let's say make some animation snapshot, delete this constraint, and constraint weapon back to this animation snapshot. Simply run constraint parent. So animation is not changed yet. We have some locator which controls the weapon behavior, and inside this locator we can create some extra locators for hands. I will duplicate it a couple of times, call it, let's say, right hand and left hand. Maybe scale it down, maybe change the color. So for the right hand, I think we can put locator somewhere here. For the left hand, we can put locator somewhere here. Put it inside the weapon. And right now, simply bake the right hand inside the right hand locator. Bake the left hand inside the left hand locator. So I can hide locators I no longer need. Maybe scale it down a little bit. So again, animation is not changed. Animation is the same. But right now, our weapon locator, it is controlling the both hands. And if we want, we can animate our extra locators, which we created for the hands separately, and achieve a better control of our animation. Again, we can create some extra layers. We can play with this locator. We can polish its curves in the wall space. See if we have any issues at some point. Maybe run curves layer filter. Okay, everything seems to be nice. If you want, we can apply some smoothing. Or we can play with the arc of the sword. But in this way, it would be much more convenient to do if we would have been animating the rig directly and constantly have to adjust the other hand. So the space switching inside is a very powerful and very wide used technique. You can use it in a lot of situations. I provided only a few examples. If you want to switch space inside manually, without the script, it can be easily done. So you need to create some locator. You can do it with a free script if you want. So we have the locator of the cube. Now we need to put this locator inside the desired object, which should be a parent, and constrain this locator to our target object. So I select the cube, the locator, run constraint parent. Now this locator, it exists inside the platform and it follows the cube. After that I would have to break the locator and delete constraint. So as a result, we got our locator repeating the cube movement, and it exists in a space inside the platform. So all I have to do is just select the locator, select the cube, and run constraint parent or constraint point and orient. And I get my animation baked inside this platform. I will delete this locator and show you that the script works in a little bit different way. Again, when I select the cube, the platform, and press bake inside, you see I don't have any locators inside the platform. It is made on purpose. The script simply creates a group which follows the platform, and inside this group the script creates the locator. Again, in my opinion, it's just more convenient to have some extra group. For example, here we have extra groups, because again, if you put something inside the rig hierarchies can be pretty large, right? If I try to find something, I would have to scroll down to find this control, and let's say if I want to delete this locator later, it might be inconvenient to look it inside the rig. So in my opinion, it is a little bit easier to create some extra group, and if something goes wrong, I can just delete this group and everything should be fine. The next thing which I want to show you would be the bake to the IK. So for example, if you have some animation on some mockup and it doesn't have IK, and you want to work with this animation, you're gonna need to bake it to some rig or do some retarget, maybe with a human IK or any other system. But actually you have a very cheap alternative. You can simply select the required bones, kind of like this, and simply press IK. And again, you got all animation baked to some IK. You can select other leg, again press bake to IK, select the pelvis, press bake to the world space, and you got all animation baked to some system of locators, and you can work with these locators same as it would have been a part of some rig, and do some, let's say, animation cleanup or work with these locators as with the rig. If you want to track different positions of the feet, so for example here the character is always jumping on this point, again you can create locator, then select the foot locator, our custom locator, bake it inside, maybe do the same for this foot, create locator, select the foot IK, this locator, bake it to selection, and now you can manipulate this character using this locator. So again, animation looks the same, but right now you have all your animation baked to these locators. You can see their real coordinates in the world space. You can work with these keys. You can apply some curve filters. If it's raw mockup data, you can smooth it, or you can fix some sliding with a fix sliding algorithm in Smart Layer, and it all works super fast, super easy, much faster than if you would have to do some retarget to some extra rig. If you want, you can create a root joint, let's say. So I can go to the rigging, create, let's say, some joint, call it root, put my hierarchy inside this root joint. If this animation is meant to be for Unreal Engine, I would have to make sure that the root joint has the up orientation. So let's simply go to the joint orient and set joint orient and -90 degrees by the x-axis. Right, so right now the root joint is static. I can select the pelvis joint, the root joint, and extract root motion. And I get all root motion on the root joint, basically in a click of one button. And I can put this animation in the game engine, and it will work just fine. And we can easily go further. For example, when I have the root motion, I can create a separate control for the root. Just simply make it to the world space, make it bigger. I have all animation on this main control. I can select the feet controls, the pelvis, select this improvised main, and bake my animation inside. So I will have all animation on this improvised main, and I can apply the smart layer if I want. Simply add it to layer as usual, set keys. Maybe let's say I want character be not in this point, but maybe in this point in the end. Simply run the smart layer with the offset algorithm, and I have all my animation shifted to the required position without any feet sliding. Or I can, for example, apply some maybe transformation, maybe rotate my animation minus 180 degrees in the end. Just run the smart layer with the transformation algorithm and specify this as a center object for the transformation. Again, run the script, and I have all the animation turned 180 degrees without any feet sliding, and all the adjustment is done basically in a few seconds using a simple space switching techniques and the animation layer. And of course you can create IK controls not only for the bones, but for example if your rig doesn't have IK, like for example this rig, it has the hands only in the FK mode. So if I would like to create an IK, I can easily do it. All I have to do is just select these three controls, press bake to IK, and I can manipulate the character hand like this. And same for the other hand. Just press IK, and basically that's it. Also you can use bake to IK to manipulate the fingers, because the fingers very often don't have any IK controls. So for example here we have some fingers on FK, and if you want to manipulate these fingers, you would have to do it through simple FK, which can be a little bit hard if fingers are interacting with some surface or with some objects, right? If fingers are interacting with some surface, for example with a table, you would like to have an IK to not animate all three segments of the finger all the time manually. So you can simply select the finger controls, press bake it to the IK, and you'll get an IK system controlling the finger behavior, which can be much more convenient to operate in some cases. So the script supports not only three objects IK, but if you want you can create IK to the tip of the finger, which would be somewhere here. For that you would need to create some extra locator. So I will select the last segment of a finger, create an extra locator, maybe scale it down, maybe change its color, and put it somewhere here. So right now I would need to parent this locator inside the finger segment. So the locator will always follow the tip of the finger. And then I can simply select the finger controls, as well as this extra locator on the tip of the finger, and simply press bake to the IK button. Okay, some IK system is created in the scene. I no longer need this extra locator on the tip of the finger. I can simply delete it, and I got an IK system in my scene with which I can control the finger using the tip point, which can be really convenient if the fingers in your scene are interacting with some surface, or you need to track the position of the tip of the finger, and it will definitely be much faster than if you would have been animating the FK controls manually, for sure. So if you would like to bake some animation to the IK manually, using only locators and constraints, it might be a little bit problematic, but it's still doable. So for example here we have this animation, and we would like to bake it to some IK. Well, obviously we could create some IK, let's say on this joint chain. Simply go to the skeleton, create IK handle, simply select required joints, and you got your IK. But here we have a few problems. So obviously this IK won't be animated. So first we need to create some animated control. It can be animation snapshot from the foot, and then we would have to calculate the pull vector position. So I will delete this IK, and you see like in the script, when we create the IK, we have additional locator, which controls the rotation of the IK chain. So let's quickly undo this. So traditionally, if we want to calculate the pull vector position, which will be somewhere here, it can be easily done with the vector mass. So I will mark the hip joint as point A, the knee joint as point B, and the foot joint as point C, just to make a better explanation. So first we need to do is calculate a vector from point A to point C, some sort of direction. It will be coordinates C minus A. Then we need to calculate some point here, like point in the middle, and this point will be this direction vector, multiply by some value around 0.5 and plus the point A coordinates. So essentially, like, direction is vector from point A to point C, right? When we multiply it by 0.5, we get vector like this, and when we add the point A, we will get a point exactly in the middle. So why 0.5? Basically, it depends on the ratio of the lengths of the bones. So this multiplier is basically length AB divided by length BC, which is 0.5 if these lengths are the same. So okay, we got our point in the middle, somewhere here, and after that all we have to do is just create a vector from this middle point to the knee, then normalize this vector and extrapolate on some distance, which would be a standard distance from the pull vector control to the knee. And as a result, we got our position for the pull vector control. So yeah, it might look a little bit complex, but if you know the ML expressions or some Python scripting, it's actually super easy to do. And I think maybe we can replicate this behavior with locators and constraints. So with locators and constraints, it can be done like this. Essentially, we just create a locator somewhere here, using point constraints from the hip and from the foot. And from this locator, which is in the middle point, we simply create an aim constraint to the knee, and then just put some locator inside, which would match to the pull vector position. So again, I will create some locator, call it, let's say, middle, and create a point constraint to this locator, constraint point, without an offset. So you see, locator is in exact middle position between these two bones, kind of like this. And after that, all we have to do is to create aim constraint from the knee to this locator. Again, constraint aim. I think aim vector and up vector basically can be any values. It doesn't matter in this case. Just press apply. Okay, so our locator is oriented to the knee. And all we have to do is just to create our pull vector locator. I created another locator, call it pull vector, put it inside the middle point, and move it somewhere here. So if I play the animation, you will see that this pull vector locator will be in exact correct position, exactly as we want. So you might get some glitches when the foot is overextended. In this case, the pull vector position can be undefined, but it is kind of normal. It is expected behavior for the vector mass. It just doesn't work exactly precise when the leg is one straight line. So okay, we got our pull vector position. I will maybe bake it, simply create animation snapshot. So I don't need this system with locators anymore. I have pole vector position baked to the locator. Next thing, I need to create animation snapshot of the foot. Call it, let's say, foot. And at this point, I'm ready to create the IK chain. So by default, your rig might not have any joints at all. It may be some just FK chain without any joints. So you need to create this joints chain manually. In this case, I think I can simply duplicate this chain. Simply unparent it. Maybe make original chain smaller. This, our extra chain, make it bigger. Maybe change the color. And basically we need only 3 joints in this chain. Only these joints. Next step would be orient these joints in one plane. Again, if you know rigging, you probably know that when you create the IK, the joints have to have correct orientations to be located in exact one plane. So personally, I just use one of my scripts. I can select my joints, press align, and it will orient these joints to have correct orientations so IK would work correctly. If you don't have any scripts to orient joints, you can do this manually. Basically, you have just to create joints and rotate them very carefully. But I think the topic how to orient joints properly goes a little bit beyond this tutorial. Basically, you need to watch any tutorial which explains how to create IK in Maya. Okay, so I got my joints oriented. I have my pole vector position. I have the foot position, so I can select the skeleton create IK handle tool, select the joints, and create IK handle. So right now with this IK handle, I can manipulate the joints. I can put it inside the foot locator, then select our pole vector locator, select IK handle, and run constraint pole vector. So right now our pole vector will control the rotation of the IK chain. The foot locator will control the IK behavior. And the last step would be to make our IK chain follow the pelvis. So I will group the joints and constrain these joints to the pelvis. Again, simply constraint parent. So when I move the pelvis, the joints chain will react to the pelvis movement. And when we got the IK working, we have to constrain the original chain to our new created IK chain. Again, constraint parent or constraint point and orient. It doesn't really matter. And for the foot, I think we can just use this locator. Simply run constraint parent. Okay, so I think animation, it looks the same. But right now, this animation, it exists on some external IK. And we can animate this IK to adjust our animation, to make some polishing, maybe fix some feed sliding. So it's not a rocket science, it's just IK. You simply bake the required transformations to locator, calculate the pole vector position, create extra joints chain in your scene, orient the joints, create the IK, and constrain your objects to this IK chain. But of course, like, you know, with the script, it can be done much quicker, much easier, because with the script, you don't have to worry about any joints. It will just work out of the box and save you a lot of time. And the last but not least feature which I'd like to show you today would be baked to the aim space. So for example here, we have some character attack animation. And as I mentioned before, when we make an animation like this, ideally we would like to track the position of the sword tip to make sure it has a clean and round movement over some curved trajectory, like some arc. And if you would like to do this by simply rotating the sword control, kind of like this, it will be a very long and painful way to do this. So I will delete this motion trail, and what we can do is bake the sword to the aim space. So the aim space works in this way. First you need to create some locators. Press this button, create locators, and it will create you 2 locators. One locator will be for the forward vector. You need to move it somewhere here. Second locator will be for the up vector. You can move it somewhere here, or maybe somewhere here, perpendicular to the forward vector. And when you created locators and move them to correct positions, you need to press this button and it will bake your object to the aim space. So animation will look the same, but right now our extra locators, which we created in the scene, they will control the rotation of the sword. Kind of like this. So you can track the positions of this locator, for example with a motion trail, and you will see a real data about the translation in the world space in the animation curves. So you can work with these animation curves to polish your animation, maybe apply some smoothing with the curve filters. So for example, if let's say your animation has some glitch and you would like to polish this arc, it will be super easy to do. You will just select an S3 animation curve and the trajectory can be polished very quickly and easy. So in this way you can easily polish any rotation for any objects, keeping the round and clean trajectories, avoid problems with the gimbal locks, and bake to the aim space. It's a very useful and very powerful feature. Personally, I use it all the time when I work with animations like this, when the character is manipulating some weapon. Again, it's much easier to bake the rotation to the aim space and work with these locators, rather than try to animate the sword control directly. And also you can create some animation layers for these locators, right? You can just simply create animation layer, add locator to this layer, and apply some adjustment in layer to adjust the whole trajectory, kind of like this. Maybe for example here, let's say it is too high, I would like to make it lower, or maybe if it's too low, I would like to make it higher. Again, it doesn't matter. With this approach you can easily polish the sword arcs, and you don't have to worry about any gimbal locks or any other issues, which you definitely get if you try to manipulate the rig directly. So after adjustment is done, you can simply select your control, simply bake it, or bake it to layer, and delete locators. And it's done just like this, basically in a couple of minutes. And another application of switching space to the aim can be creating a secondary motion. So for example here I have a scene with some cubes moving, and if you would like to create some secondary motion, we can do this manually. So traditionally what I was doing for many years would be to create some rotation curves on these cubes, kind of like this. So the animation would look like this, and after that I would simply offset these rotation curves in time. So when the cube goes up, the rotation should be like this. For the next cube, the rotation will be maybe like this. For the next cube, maybe will be sort of like this. So as a result, we get some kind of overlapping animation. Maybe we can make the offset in time even bigger. And you can always do this process manually, no problem with that, but it kind of takes a lot of brain power to calculate the correct rotations and correct offsets. So a few years ago I saw a little bit different way to create the secondary motion. I believe I saw it on the Pavel Barnev channel, and I think it is a very smart way to create secondary motion. Let me show the idea. I will delete these rotation keys. So what we can do is to bake this cube to the aim space. Again, create locators. I need to move forward locator here. Then I need to move up locator somewhere here. You know, in Maya you can actually jump between locators with the arrow hotkeys. So I will delete these locators just to show you the idea. When I create the locators, first will be the locator forward. Then I can simply press the arrow key to the right, and I will select the locator up. Again, I will move it somewhere here. Then I simply press bake to the aim, and I got my animation not changed. But what is interesting, if we select our forward locator, and shift its keys in time, for example like this, we got a sort of a secondary motion. I will quickly undo this, because in order this trick to work, we need to have a bigger timeline. So again, I will create locators to bake it to aim, move the forward locator here, move the up locator here, then bake it to the aim, then offset in time the locators to get the desired secondary motion. Then I can select the next cube, again create locators, move forward locator somewhere here, move up locator somewhere here, press back it to the aim, again apply a little bit of offset to get desired secondary motion, then do the same for the next cube, and I got the secondary motion basically in automatic mode. And this is actually a very simple, very robust way to create secondary motion. If you don't have any automated physics tools in Maya, you can use this way. I mean, why not? So after the adjustment is done, you can bake it to the original animation, or maybe bake it to layer, and delete locators. And with animation layer, you can also play with the opacity. This is without any overlapping motion. This is with overlapping motion. Again, you can choose how much exactly overlapping motion do you need. So this is a very simple technique, but potentially it can save you some time during animating. And maybe we could try to apply this technique on a different animation. Again, for example, here I have the attack, and I know the hair of this character should be animated with some secondary motion. So I got hair controls here. I can create locators, move forward locator somewhere here, move the up locator somewhere here, bake it to aim, shift keyframes a little bit, kind of like this. Again, do the same for the next control. And basically in a few minutes I got some sort of secondary motion on this hair. I will isolate the hair just to show you the animation, and you can see that this particular piece of hair, it is animated like if we used some sort of physics in the scene, but actually all of it was done with simple locators and constraints. So here in the scene I actually have some additional joints. So if I would like to animate all hair in this way, it will be a little bit long. Maybe some overlapper scripts can be used in this case. Personally, I prefer to animate stuff like this in engine directly, because it's just faster and easier, and you can set up the simulation in engine separately. In case you want to adjust this simulation, you won't have to bake all animations, so it's kind of a safer approach. But again, if you do simulation in engine, it might be a little bit heavy. So depending on the circumstances, you can do simulation on joints in Maya directly. It kind of depends on your pipeline and your personal preferences. And if you would like to bake something to the aim space manually, it can be easily done. So all you have to do is just to create two locators. Basically locator 1, locator 2. One locator will be forward vector. Second locator will be up vector. So you move forward locator somewhere here, up locator, let's say somewhere here. Maybe you can assign some different colors. So right now these are just locators, and you have to constrain these locators to your object. Simply run constraint parent. Again, I'm constraining locators to the sort, constraint parent. So these locators will follow the sort movement, kind of like this. Then I need to bake animation of these locators. Simply bake and delete constraints. So I got animation of the sort baked to these locators, and all I have to do now, I would have to select this locator, the sort, and create constraint aim. So in the aim, we would have to carefully specify the aim vector, which would be Z in this case. So it will be like 0, 0, 1. The up vector will be Y, which will be 0, 1, 0. World up type will be object up, and as a world up object we have to specify the name of our up locator. Yeah, this is done super inconvenient in Maya. I don't know who designed this system, but it works like this. You have to specify the name of your up object here. Okay, so the name is specified, the vectors are correct. Simply press add aim constraint. So right now our locators, they control the rotation of the sort. And we can work with these locators to polish the animation, maybe to visualize the motion trail, work with the keys of these locators in the world space, apply some curve filters if you want, do some adjustment. After the adjustment is done, we would have to just bake our object and delete these extra locators. So in this way you can bake any object to the aim space, clean up rotations, avoid gimbal locks, and do a lot of cool stuff. Okay, this might be it. I know this tutorial probably wasn't the easiest one, and again, because the space fishing is a very wide and complex topic, and we had a lot to discuss, I hope you find something of this useful. I think I covered almost everything in Smart Layer. We discussed almost all algorithms. There are still a few things which I would like to say about the offset by spline, and maybe about how to deal with the human IK animations. If you have any topics in mind which you are interested in, you can let me know in the comments. And for now, I thank you very much for watching this series of tutorials and hope to see you next time.